So coming to the calculation, we have impedance calculation for first transformer 1, which is 2 kVA rating. So first we calculate ZA, which is obtained by VSC by ISC. As per the reading that we have got, VSC is 16, ISC is 8.7. If you take the ratio, we will be getting 1.83 ohms. Then we will be calculating resistance RA, if we call this as transformer A, WSC by ISC square, which will get us 60 by 8.7 square, which is 0.793 ohms. Then we calculate the reactance XA, which is given by root of ZA square minus RA square. If we substitute the values, we will be getting 1.659 ohms. Impedance is given by R plus JX in general. If we express the same in polar form, we have magnitude at an angle, ZA at an angle phi A. So first we write down ZA in rectangular form, which is RA 0.793 plus JXA, which is J 1.659, and if we express the same in polar form, we have 1.838 at an angle 64.45. So same calculations have to be performed for second transformer also, which is of the rating 1 kVA. From the short circuit test, whatever readings we have got, if we do the same calculations, we get ZB 2.298, RB 0.6341, XA 2.2096, ZB 2.298 at an angle 73.98. Next, we calculate the power supplied by both the machines. First, we calculate for transformer A, which is of 2 kVA rating. For calculating the power supplied by machine A, we first find out IA dash, which is given by IL at an angle minus phi L multiplied by ZB at an angle phi B divided by ZA at an angle phi A plus ZB at an angle phi B. So this has to be expressed in polar form. So we can represent this as magnitude of current at an angle minus phi A, where in this expression we have phi L, that is obtained by cos inverse of WL divided by VL IL. So IA dash is given by 2 at an angle minus 56.25 multiplied by 2.29 at an angle 73.98 divided by 1.83 at an angle 64.4 plus 2.29 at an angle 73.98. After simplification, we get 1.11 at an angle minus 52.015 amperes. Then we try to calculate the kVA, that is the kVA capacity. QA dash is given by QL at an angle minus phi L multiplied by ZB at an angle phi B divided by ZA at an angle phi A plus ZB at an angle phi B. And again we are interested in expressing this in polar form, QA dash at an angle minus phi A dash. Generally, the notation for kVA is S, but here we have used Q for denoting kVA. Usually Q is a standard symbol used for representing reactive power, which is kVAR, but here we have used Q in order to denote kVA for our understanding. So QA dash is given by the above said formula. So if we substitute the same, we get 260.89 at an angle minus 52.015. So after getting kVA, if you multiply kVA with cos phi, we should be getting the power supplied. So WA dash will be QA dash multiplied by cos phi A dash. So if you multiply the same, we have 160.567 watts. Similarly, we calculate the power supplied by machine B or transformer B, and we have IB dash is equal to 0.8919 at an angle minus 61.24. We get kVA QB dash 208.709 at an angle minus 61.54, and we get WB dash, which is the power supplied, which is kVA multiplied by cos phi, is 208.709 into cos of 61.54, which is 99.45 watts. So after doing these calculations, we come to a conclusion that for this particular load, for the current of 2 amperes, which is the specimen that we have selected for this calculation, load shared by the first transformer of 2 kVA rating is 160.56 watts, and load shared by second transformer of 1 kVA rating is 99.45 watts. Similarly, load shared by transformer A and transformer B for all the readings have to be calculated. This finishes the calculation, specimen calculations for this experiment.